Okay, so today we're going to be looking at just some general problem-solving techniques for trigonometric problems. Give you some definitions of some things that will help you understand how to draw pictures and such from your word problem that you're going to be getting. A couple of them are real important ones. What is an angle of depression and what is an angle of elevation? Basically, the angle of depression and angle of elevation is an angle that is formed by your line of sight and you're looking up or down. So a depression is, here's a little body person right here. If I look straight ahead horizontally and then look down at an object, the angle formed right there, that is the angle of depression. Over here, this person right here looks straight ahead and then looks down here, angle 3 would be the angle of depression. But if they look upwards to this person, then that is an angle of elevation from the horizontal upward. So 2 would be an elevation angle, 3 would be a depression angle, 1 is a depression angle, and this person looking up here, 4 becomes an angle of elevation. This is important to recognize this so that when you draw your pictures and they talk about angle of elevation and depression, that you start with the horizontal line and then look up or down so that you have the proper angle. Once you have that angle, then your task is to get an angle inside of your triangle. So that's why it's important to recognize these two definitions to help you in solving problems. So here's some guidelines that you want to go through. Okay, as you start going through working problems out and seeing what they're saying, you want to draw and label a picture with the information that is given. Okay, usually it's going to incorporate some right triangles or some kind of triangles. Whatever they describe, try and draw it. Put yourself in the situation to help you in visualizing what this picture should look like. Identify what you're asked to find. Okay, what am I asked to find in this problem? This leads you towards a process like what trig function to use. Do I need to use Pythagorean theorem or some other technique to help get what I'm looking for? Once you've done that, identify angles and lengths that you can deduce from the given information. So if I gave you 3 sides of a right triangle, I can use Pythagorean theorem to find the third side that I might need to help me solve this problem. So things like that. Or for angles, look at the angle of depression and elevation. Notice these dotted lines? They're all horizontal, which means they're all parallel, which means I can tell you about angles, alternate interior angles are congruent, things like that. Okay, so that can help us find angles. Based on the information, determine the most appropriate method. If I have right triangles, I can use Sakatoa techniques. If I have non-right triangles, I got loft sines or cosines I can use. And then the last one is always answer the question in context to what they were asking. Make sure you've answered the question and you use the context to help you. Don't just throw a number and circle it. What does that number represent? What does it mean? Things like that. So let's solve a couple of problems and then we'll do some more together in class. So here's a first problem that we see. They gave us the picture associated with it. So Sam sees a tour bus from the top floor of his hotel to the nearest foot. How far is the bus from the base of the hotel? So we want to know, what is that distance from there to there, to the nearest foot? So we draw a picture. Here's the building. We draw a line of sight to the bus. We label, here's the ground. Okay, don't forget to put the ground in. And then we have here, as this is an angle of depression. So from the horizontal downward towards the bus, this angle is 23. But notice this is a right triangle. All buildings are right angles to the ground, okay, except for the Leaning Tower of Pisa, but that's a problem we'll talk about later. So I have a right triangle. I know I can use the Sokotoa techniques for right triangles, but I have to have an angle inside this triangle, and I don't. 23 degrees is not in this triangle. It's outside of it. So this is what I was talking about. You need to use information, our rules and such, or our theorems and stuff. Can I get an angle, knowing this one, can I get an angle in here? And the answer to that is yes. There's 2 different ways to do it. One method is, because this is horizontal and the ground is horizontal, they're parallel lines to each other, which makes this a transversal which makes this angle and this angle congruent because they're alternate interior angles. So that is one way to get an angle in here. The other way to get an angle in here is because this is horizontal and this is vertical, this is a 90-degree angle up here also. So I can do the complement to 23. In other words, what is 90 minus 23? Then I can put that angle in here at 67. So I can use that technique to get an angle up here. And depending on which method you use, you don't have to do them both, you just have to do one of them. Once I have an angle in there, then I can do a trig ratio for that using the SOHCAHTOA technique. For the original one, the 23, here's my angle. This is opposite that angle, and this is adjacent to that angle. So opposite and adjacent is the tangent. So I would write the tangent of 23 degrees is the opposite over the adjacent. And then I just do our cross multiplication technique for this, and I end up getting x equals 180 divided by the tangent of 23 degrees. And then I can use my calculator to approximate this answer. And I have done so already, and you get 424.053 if I round it to 3 places. And so I have a number. Now I go back to the question and I say, okay, how is this number going to be used in this problem? What are they asking for? To the nearest foot, how far is the bus from the base of the hotel? See, this is not the nearest foot. This number rounded to the nearest foot would make this answer 424. In context of this problem, the bus is about 424 feet from the base of the hotel. So use the question to answer the question. And there you go. That is your answer in context. Okay, let's look at another problem. So here I have this one. It's kind of hard to see the picture a little bit, but you can look closely at it. And what I have here is I have a right triangle. So the big triangle is a right triangle. The hypotenuse of that right triangle is 61 feet. I have a whole angle down here. So the angle at this side is 79 degrees. There's an inner triangle right here, and that angle is 75, which makes this little sliver angle over here an angle of 4. Okay, so this little y degree is 4. Our goal here is to figure out what is the distance from C to R. What is that distance right there I'm going to call A. So we got to look around here and see what was the best way to do this. I can't use the small triangle where A is the hypotenuse and this angle is 75 because I don't have any side lengths. I need at least one side length. And the only thing that has side length is this side over here. So can I use the big triangle? Well, I can, but A is not part of the big triangle. So I'd have to do multiple steps. So the other question that I would ask is, can I find all these other angles that are floating around? Well, I found this little one here is 4. So that one over here is 4 degrees. If this angle right here, this big one right here is 79, by the complement, this little sliver up here must be 11. Because 79 plus 11 is 90. Remember, this is a right triangle. Well, if this little angle here is 4 and that little angle is 11, that's 15, then I can find this obtuse angle right here called x. I can find that by subtracting from 180. And when I do that, I get, I believe it's 165. So if I look closely at this little small triangle, this small obtuse triangle that's up here, if you look closely at it, I now have all 3 angles and a side, which means I have a complete ratio, which means I can do law of sines. The sine of 165 over 61 is equal to the sine of 11 degrees over A, the thing we're trying to find. That's how you go about doing problems. You start, what do I know? What do I know? What can I do? Start finding all those things, and then helps you determine the best approach once you start seeing some patterns that are emerging. Cross multiply all this out, solve for A. So A is going to equal, multiply the diagonal, divide by the third number, 61 times the sine of 11 over the sine of 165. And we can type that in the calculator. I've already done so. And you get 44.971 feet. Okay, now they didn't tell me to round off, so I can use that number right there. But in answering this question in context, I can just simply say that they ask how far is the student from the instructor at the resting point R. I can say it's about 45 feet. Okay, that is one option that we can do. Let's look at something else that's kind of interesting, and that is that the area of a triangle can now be modified using trig functions. And here's how. Here's a triangle. Here's the base. Here's the height. The area of a triangle is 1/2 the base times the height. Okay, the height. And so, but I can use, if I look at this thing, I can use, here's angle A. I can use the law, I use sine Sakatoa, and I got the sine of this angle is the opposite over hypotenuse, h over c. And then if I solve this for the height, I get this trig expression right here. If I then take that trig expression and substitute it for the h, then I get this equation. And this equation allows me to find the area of a triangle if I know an angle and the two adjacent sides to that angle. And so that is an alternate method for finding the area of a triangle. And here it is from the area from each of the three angles. How you would do it. It's basically using side angle side technique. So here's how it would work in this problem. I have a triangle ABC. Here's the information. Angle A is 59 degrees. What I'm going to do first, and always, is draw a picture. So here's the base, and I'm going to draw a 59-degree angle or something close to it. So this is going to be 59 degrees. This is angle A. And then I'm going to put a dot up here, that's B. So that means this distance is 13. If I connect the triangle, then this is side C, angle C, excuse me. And so AC has a distance of 15. And I see that I have the side angle side of this triangle. This allows me to use the formula. So my area is equal to 1/2 the base times this side times the sine of this angle. Okay? And then I can just type this into the calculator and get an approximate answer for this. So the area here is approximately equal to 83.574. And it says round to the nearest tenth. So here I rounded to 3, so I'm going to round it to the nearest tenth, and it gives me 83.6. And then you would have to have some kind of unit if one was given. If none are given, like in this case, you simply write square units. Okay? Because areas are in square units. And since you don't know the units, just write square units down. So this is an alternate method for finding the area of a triangle if you have an angle and some of the sides. And so that concludes this chapter in this section, and we'll do more problems together in class.